In this video, we are going to look to see how Jamovi can quickly give us some basic statistics and even do some comparisons between multiple groups. Okay, so let's consider our following scenario. Answer the following question with respect to these daily high wind speeds for Casper for the past 40 days. All right, let's go ahead and click on data, and we have Casper wind speeds, and we have in miles per hour, and we have weather type, whether it was kind of like a rain or a snow day, or if it was clear. Okay, so let's go ahead and copy in our data. Copy and paste. Let's do a little bit of manipulation on our variables. Let's just do wind underscore mph. And this one is in fact continuous in decimal, so it got that one right. That was very good. And let's go over to our next one. And we'll go to weather. And it is in fact nominal, and just text is our data type. If you want to switch the order, you can. No real reason to, but we are good there. All right, let's bring that up. And let's get rid of our data. Now, we're going to round our answers to 3 decimal places, just so that we have that heads up. First thing that we want to know is just general summary. We're looking for like mean, median, standard deviation, variance. Like in the videos we showed you, or you can do these by hand. Like you can absolutely do these by hand. But when you're starting to deal with 10,000 data points, you are going to make mistakes with your hand. It would take forever to do. And we have great tools and great software that we can use to quickly get us these values. Okay, so let's take a look at what we can do. So the first thing, if we go to exploration and we go down to descriptives. Now what it's asking for us is to put in our variables to get our kind of general summaries. So the first thing that we're going to do is let's just toss in wind speed. And let's toss in weather in both of our variables. And let's see what type of samples summaries that we get. Okay, so we get some basic stuff here. We get some so we get the mean, median, standard deviation, min, max. If you notice right here, I have a ton of decimals being given out. If you want that many, great, that's fine. If you want to kind of rein it in a little bit so that it's not quite so much, we can always go up to these 3 dots right here and change the number format and the p-value format. And this says it out at 16 decimal places. And let's go ahead and just drop this back down to 5. And we'll do 5 here as well. And now it's a little bit easier to see. Now we've got a couple more decimal places. But if you really, really want all the way up to 16, you can grab 16. Oh, and you can also choose, instead of decimal places, you can do significant figures. I'm just going to grab 5 decimal places for this guy and 5 decimal places for this guy. And there we go. That's a lot easier to look at. Okay, so mean, we can just grab straight across 16.033, or you could just highlight and copy this whole thing. It only has to be accurate to 3 decimal places, but if you put in more, that's totally fine. Okay, so that's the mean. Sum all of the wind speeds up, divide by 40, because that's the total number of entries we have, and that's our mean. Median is we put them all in a row from the smallest to largest, and the middle value is our median, and we grab our median. Standard deviation, here we go. It's one of our measures of kind of spread, of how spread out our data is. And you can go back and look at our equations if you want to do it by hand, but we get this 4.3905, very good. And then it also asks for a few other things. Variance we don't have here. We could get it easily. You could just square the standard deviation. Remember, standard deviation is just the square root of the variance, or variance is just the standard deviation squared. So we can grab that too. If we go to our statistics, click over here, we can just include the variance right here, and it gives us 19.277. Click on this, 19.277. Excellent. All right, minimum and maximum. So it asks for our max. We've got, this is just the largest wind speed that we saw, 27.299. Minimum is 7.62. Range. We could do the just subtracting the minimum from the maximum, or again, We just go to our statistics and click on range, and it gives it to us. There's our range. Okay, so the other thing though that we're looking for is also the proportion of rain versus snow days. Now if we look up here, it really doesn't give it to us at all. We're kind of missing this piece. So what we can do is we can actually include in a frequency table. And a frequency table will let us know how many of these rain and snow days do we have. So we have the counts, 20 rain and snow, 20 clear, so that's 50% of each. Remember, I am looking for this in decimal form, not in the percentage form. So all we have to do is click here, and we see that it's 0.5. So that's how we kind of grab those basic values. Now if we go down, we can also see that there are some additional questions we have. So it says, of the recorded days, where rain and snow or the clear are found to have a higher mean wind speed. Okay, so we actually want to, in this one, compare the descriptives between the groups. All right, so in here, I'm going to actually take weather out now. Let's move that guy out. And we're going to take weather and we're going to split it by, or we're going to make the groups. Now we can actually compare the different groups for the different if you want to compare the means, the medians, or whatever. So this is one output that you can see kind of with it in the variables across the columns. I actually like variables across the rows a little bit better because I think it's easier to see. So let's go back to the data and let's see what we've got. Okay, so on the recorded days, we're looking for the higher mean wind speed. So if we look at the mean wind speed, we've got rain and snow was 17, clear was 14. So rain and snow had the higher mean wind speed. Okay, great. Of the recorded days where rain, snow, or the clear found to have a higher standard deviation, which one was more spread out? Rain and snow has the higher standard deviation than the clear. Okay, new question. Now consider the next day was added to the list. So like day 41, which had a wind speed of 100 miles per hour. Which would be more affected? The mean, the median, or were they like equally spread out? So this one, typically, it's not always, but it's typically that the mean is more affected than the median. And the reason why is because the mean is affected by outliers. Big outliers can pull the median towards that, or pull the mean towards the outlier more than the median is. If a single day is just added in, remember, the median just kind of shifts up just like one little spot or like a half spot from where the middle is. So once again, means are much more affected by large outliers than medians are. And the mean will be pulled in the direction of the outlier. All right, so if we look at this, let's look at our defense. So since the mean is an average of all numbers, the big outlier greatly influences it. Okay, excellent. Next, we got a couple little calculations to do. Okay, so let's assume that the daily average wind speed follows a normal distribution and that the sample mean and the sample standard deviation are really population values. All right, we'll talk about that in just a second. Considering the 100 mile per hour speed, how many standard deviations above the mean is that outlier? All right, so let's go ahead and grab Excel real quick and we'll do just a few basic calculations. Oops. Okay, give me just a second. Oop, I got a couple things popping up. Okay, so. All right, so if we remember that when we are doing a z-score, we're using this equation. Z equals x minus mu divided by sigma. All right, so it means that x is our observation. Mu is equal to the true mean. And sigma is equal to the true standard deviation. And the z-score lets us know how many standard deviations away from the mean is that observation. Okay, so if we did this, we could say that x, the observation, would be this 100 miles per hour, this new outlier. The true mean of, and we're looking at just the wind speed, so we're looking at, okay, let's combine these things back together again. So we probably got to go back in and let's fold the numbers together again. Let's go back to our analyses, and we are going to pull out weather again. Okay, and so our mean here is this 16. Let's grab this 16.03275. And our true standard deviation is 4.39057. Okay, so if we want to know is how many standard deviations above the mean is that outlier, we just need to calculate out our z-score. So we can just say equals this x minus the mu divided by sigma. And we can hit enter and we get this 19.1245. Okay, so there we go. We've got this value right here. And then it says, still considering that 100 miles per hour wind speed, what is the z-score? And it's not really a trick question. It's just making sure that you know what this is. It's the same thing. So the z-score does let us know how many standard deviations above the mean an outlier is when we're talking about this normal distribution. Okay, so that is how we do some basic calculations and some basic utilization of Jamovi in order to get us general summary statistics and how to do a basic z-score calculation. Best of luck to all of you in using these tools in your own problems, homework, and just calculating out descriptives.